So picking up where we left off, we talked about the semi-metals or the metalloids. Those are those 7 elements between groups 13 and 16, and they run diagonal. Okay, you should have drawn that line. It looks like a staircase. Okay, um, these elements are going to have, again, those properties that are both metal and non-metal. They're kind of have both. They don't really fit in either category. Okay. So you don't have to write this down. You can just take a look at it, but we're just looking at these metals that way. Okay, so let's talk about our groups. So you're going to need several colored pencils. Okay, you don't have to color them exactly like this. The only thing I'm going to tell you is that on your sheet that has all of the, so it's the other yellow sheet you haven't worked on yet, your yellow sheet, you're going to color the box the same color as you color that column or that section, okay? And then you're going to write some information underneath each one, okay? So your first group, okay, is column 1, and this is your alkali metals, okay? So you want to color that one color and then match it to the box. Column 2 is your alkaline earth metals. Okay, you're going to have to skip some on here because transition metals is at the bottom of your page. But your transition metals is that squatty little rectangle in the middle. So it's this section right here. Okay. Next, starting in column 13, you have boron group. Okay, again, coloring as you go, matching your box to your row. Then you have the carbon group, makes sense. So you can kind of see a pattern. Okay, so this group is the nitrogen group. Okay. This next group, Miss B always has a hard time saying, okay? This is the chalcogen group, okay? So chalcogen group, that's oxygen group, okay? Then group 17 is your halogen group. Really know the halogen group, that's really important. We're gonna see this a lot. This group likes to bond. It has its own activity series, so really know that halogen group. Okay, and then finally is our noble or inert gases. Okay, this group, really love this group because it doesn't really do anything. Okay, this group is happy all the time. I'm going to compare a lot of our stuff to our noble gases. So think of them like kings. Okay, and then at the bottom, okay, and at the bottom, you have your lanthanoids. That's the first row across. And then you have your actinoids, which is your bottom row across. So that's your 2 groups there. So take a moment and color, make sure you're matching your colored row to your box, and then we're going to talk about them. So your groups. So underneath alkali, so your metals, your 1A. So make sure you put 1A next to alkali metals. Okay, they're super reactive. And I'll put up some videos a little bit later of showing you how reactive they are. But pretty much if you drop sodium, potassium, cesium in water, it's gonna explode. They're soft, silvery color, they're shiny, which is you wouldn't expect, but they are, because when you think of sodium, you think of salt, right? The salt you put in your, mashed potatoes or your pasta or whatever. But it is really shiny. If you ever took it out, you would see that light reflects off of it. Okay, column 2. Okay, underneath alkaline earth metals, 2A. They're less reactive, okay? So they're not going to be as violent when it comes into contact with water, okay? They're silver colored, they're high density, so they're going to feel heavy, okay? If you took a block of calcium, it would feel heavy, okay? All right, boron group, that's 3A. The reactivity varies because this is the group that's going to start transitioning into those metalloids. They're mostly solid at room temperature, okay? All right, carbon group. Again, their reactivity varies as well because now some of them are in the metalloid section. So it's going to vary on what's happening. And these are all solid at room temperature. Okay. Your nitrogen group. Okay, again, that reactivity varies again because we have a couple of those metalloids in there. Okay, they're all solid except for nitrogen. Again, if you look at the periodic table on my wall, you see that nitrogen's red. Red means it's a gas, and then everything else is black, which means they're solids. The chalcogen group, okay, that's the one with oxygen. They're mostly nonmetals. I do have a couple metalloids, okay? I do have a couple metalloids. They're highly reactive. When we talk about reactivity, again, I said in the first one, the first ones are gonna have an explosion. But when I say reactive, it means that these elements are going to want to bond with other people. Okay, so that means to be highly reactive. And they're all, again, solid except for oxygen, and you can see that on the board. Okay, halogen group. They are extremely reactive, which means they are trying to bond with anything and everything. They are like the hose of the periodic table. They are trying to get with anybody who will get with them, okay? Because of this, they react violently with alkali metals to form salts. So that, again, table salt you're putting into your pasta, your macaroni and cheese, your mashed potatoes, that salt, when it was created in a violent reaction, okay? But you wouldn't know that because you just see the nice little crystals, okay? They're never uncombined with another element. So they either need to combine with someone else, like sodium, or they're going to combine with themselves, and that makes them what's called diatomic, which means that you have to have two. The best way to think about a diatomic element is the fact that these elements are like 4-year-olds. You cannot leave a 4-year-old alone, so you cannot leave these elements alone. There's a couple other diatomics we're going to talk about, but just know pretty much mostly column 17, with the exception of AT, is going to be diatomic. It either needs to be bonded with a different element or it's going to bond with itself, okay? And these are poor electrical conductors, right? Which is good. We don't want to be mixing violent reactions with electricity as well, okay? Finally, our noble gases, they're nonmetals, and you can tell because they're in the nonmetal group and they're all red. They're mostly non-reactive because they do not want to combine with other elements. Okay, they're pretty happy, and that has to do with their valence electrons. Remember, those valence electrons are the electrons that are outside on the outermost shell, and so they already have enough. So they're not trying to take electrons. Not trying to take electrons, they're not trying to keep electrons, they are happy the way they are. So that's why they're non-reactive. They're colorless, odorless gases. Again, you can see that they're all red on my board, okay? You can make color by putting electricity into them. That's how a neon sign works. But for the most part, if you just have neon, you're not going to see it. Your transition metals, that's that squatty block in the middle. They're all metals. They're shiny. They're going to be great conductors of heat, that's thermal, and electricity. So you definitely do not want to be mixing that stuff together. And then next is your lanthanoids and your actinoids. Those are that 2 lines at the bottom. So the way these work is, and if you watch the video with Hank, he talks about how they need to be put in. So what's going to happen is, if you notice on the periodic table, there's a block that says like 58, 59 through like 70 something, and then there's another one below that as well. What that means is you have to put that row in there so it extends the periodic table longer, and that would just be crazy. So we just kind of took it out, but that's really where they go. They go in that section right before the transition metals. Okay, so our lanthanoids are shiny, they're reactive metals. Actinoids are pretty much our radioactive material. Okay, if you notice, you have uranium down there, you have plutonium, neptunium, okay, thorium, Miss B's favorite element. They're unstable, okay, maybe that's why Miss B likes thorium, because she's unstable too. Okay, it's unstable. These are the ones that are going to go through a lot of radioactive decay, okay, shooting off alpha particles, beta particles, just like you learned in nuclear chemistry. that's all for this lesson. We're going to talk more about valence electrons. We're going to talk more about how our periodic table is working, but know this, our periodic table works by organizing our number of protons. Every element has its own set of, or its own number of protons. Okay, there's none that repeat, and each element is increasing as we go across the board. So as we go across the board, we increase our number of protons, and as we go down, we're increasing the number of rings to collect our electrons. Because remember, in a neutral atom, which we're talking about right now, we haven't talked about really changing them, our electrons will match our protons. And so we're going to put those together. Okay. So finish coloring. Again, take that yellow sheet of paper that you just wrote on, tape it or glue it to your periodic table you just colored. Okay. And then you are going to put that in your notebook.